Good day everyone. Today let us see few MCQ sums. Okay. For your semester 1, you all know that you have only MCQs. Today let us see few sums from continuity and differentiability. The first sum, if f of x is equal to 3 sin pi x by 5x, x not equal to 0, 2k if x is equal to 0 is continuous at x is equal to 0, the value of k is, and they have given you 4 options. Actually, for doing the continuity sums, you should all know 3 important limit theorems which you have studied in your 11th standard. When you get any trigonometric function, you should know limit theta tending to 0 sin theta by theta is equal to 1. That is the one we will be using. So, if you look at this one, it is x not equal to 0. That means your f of x is same for both LHL as well as RHL, right? So, now let us write the f of x is equal to 3 sin pi x divided by 5x. Now, the 3 and this 5, they are only constants. So, let me write the 3 by 5 here. I have a sin pi x, that means in the theta place I have pi x. Here I have 1x. So what I am going to do? I am going to multiply the numerator and the denominator by pi, so that this part will become of the form sin theta by theta. Whatever is here, you should have it here, right? So now let us take limits. So limit x tending to 0, f of x, that will be equal to limit x tending to 0, 3 by 5, you can write even outside the limit, nothing wrong. So, sin pi x by pi x. This pi is also a constant, so I will write here. You know this is 1. So, you will be actually getting 3 by 5 pi into 1, which is 3 by 5 pi. So, this is the LHL as well as your RHL. That is why I have just put a 0. Otherwise, for LHL, you will put 0 minus. For RHL, you will put 0 plus, right? So, now we have got it. Now, what is f of a? That is when x is equal to 0, it is given as 2k. You know, if your function is continuous, the LHL is equal to RHL, that is equal to f of a. So, now you can equate 3 by 5 pi, that is equal to 2k. K you keep here, this 2 you bring here, you will get 3 pi by 10. This will be the value of k. Check the options now. You are getting option B, that is 3 pi by 10. So, if you know the basic concepts of continuity and the 3 important theorems in limits, you will be able to do the sum here. Hope this sum is clear to you, right? Sum number 2. F of x is equal to x by mod x lesser than 0, minus 1 when x is greater than or equal to 0. It is continuous. They have given some conditions like the value of x belongs to R, or x is equal to 0, or x belongs to R minus 0, or x is equal to minus 1 and plus 1. You have to find what is the condition, what is the x value if the f of x is continuous. So now, here, this is the LHL. For LHL, your f of x is x by mod x. For RHL and your f of a, it is minus 1. So, let us first take the LHL part. Your f of x is equal to x by mod x. You know x is lesser than 0. All of you know a mod function, right? Mod x, that will be equal to minus x when x is lesser than 0, and mod x will be equal to plus x if x is greater than 0, isn't it? This is the mod function. So now, your f of x, because it is x less than 0, that will be x by minus x, which will be straight away equal to minus 1. So you need not actually take any limits. You have got a constant. So the LHL is minus 1. The RHL is minus 1. And f of a, that is also minus 1. So that is the condition for continuity. LHL is equal to RHL is equal to f of a. Therefore, whatever may be the value of x, that is when x belongs to R, your f of x will be continuous. So the option A is your correct answer. Do you follow? Third sum, f of x is equal to 2x. G of x is equal to x squared by 2 plus 1. Two functions are given. Which is discontinuous is the question. Option A, f of x plus g of x. Option B, f of x minus g of x. Option C, f of x into g of x. D, g of x by f of x. Now, first let us check f of x and g of x, how they are, whether they are continuous. Both are actually polynomials in x. So, a polynomial is everywhere continuous. You should know that property. So, f of x is continuous and g of x is continuous. When two functions f and g are continuous, you know f plus g is continuous, f minus g is continuous, and the product f into g is also continuous. But when you come to the division, if it is g of x by f of x, if your f of x is equal to 0, then it will not be continuous. So that condition is there. So these three options are definitely continuous. This is the only option. There is a possibility that it is discontinuous because your f of x, there is a chance of being 0. Okay, so that is the option you have to take. These are all based on the concepts only. There is no working necessary for these sums. Let us see the fourth question. F of x is equal to cot x is discontinuous on the set x is equal to n pi, n belongs to z. X is equal to 2n pi, n belongs to z. X is equal to 2n plus 1 pi by 2, n belongs to z. X is equal to n pi by 2, n belongs to z. Now, f of x is cot x. How can you write cot x? Cot x can be written as cos x by sin x. You know, when it is of the form some f of x by g of x like a quotient, the denominator should not become 0. Then it will not be continuous. So here the sin x should not be 0. When will sin x become 0? You know, sin 0 is 0. Sin pi is 0. Sin 2 pi is 0. Sin 3 pi is 0 like that. Or we can generalize n pi, if it is equal to 0, then sin x will become 0, correct? So now x, if it belongs to n pi, then this will become 0, then this is discontinuous. Now check the option. It is option A. X is equal to n pi and n belongs to z. If that is the case, the cot x will be discontinuous. Do you understand? Here, let us just take, instead of cot x, supposing they have given you tan x. Just let us take, they have given you tan x. How can you write tan x? Tan x can be written as sin x divided by cos x. Now this cos x should not become 0. You know, cos pi by 2, cos 3 pi by 2, cos 5 pi by 2, cos 7 pi by 2, etc. will be 0. That is, odd multiples of pi by 2 for cos theta, that will be 0. So, what is the generalization of odd multiple? It is 2n plus 1 into pi by 2. This will always be an odd number because 2n will definitely be an even number for whatever values of n. If you add 1, that will become an odd number. So, 2n plus 1 pi by 2. If your x belongs to that, in that case, that tan x will become discontinuous. So, like this you have to think. So, like that they can ask for tan x, they can ask for secant x, they can ask for cosecant x. Check the denominator and see for what values that will become 0. In that set, it will become discontinuous. Is it clear? Fifth example. F of x is equal to mx plus 1, x lesser than or equal to pi by 2, sin x plus n, x greater than pi by 2. F is continuous at x is equal to pi by 2 and they have given you 4 options. M is 1, n is 0, m is equal to n pi by 2 plus 1, n is equal to m pi by 2, n is equal to m is equal to pi by 2. So here, when your f of x is, that is the LHL, and f of a, it is mx plus 1. So let us write first LHL. Your f of x now is mx plus 1, right? Now let us take limits. So limit extending to pi by 2 minus f of x, that is equal to limit extending to pi by 2 minus mx plus 1. Whether it is pi by 2 minus or pi by 2 plus, in the place of x you have to substitute only pi by 2. So you will be getting here m into pi by 2 plus 1. So m pi by 2 plus 1. This is the LHL. Now let us go to the RHL. For RHL, the f of x is sin x plus n. Now let us take limits. Limit x tending to pi by 2 plus f of x is equal to limit x tending to pi by 2 plus sin x plus n. Okay. So now you put pi by 2. You will get sin pi by 2, that is equal to 1. So 1 plus n. So this is the RHL and this is the LHL. Because it is continuous at x is equal to pi by 2, we can equate both. So what do you get now? M pi by 2 plus 1 is equal to 1 plus n. The 1 and 1 you can cancel on both sides. So you get n is equal to m pi by 2. This is the relation you get. Check the options. You get n is equal to m pi by 2. So option C is the correct answer. Is it clear to you? The sixth sum, f of x is equal to mod 2x minus 1 into sin x. It is differentiable in, and they have given you 4 options. Now, it is something about differentiability, right? You know, if a function is continuous, then only it is differentiable. At the same time, if it is continuous, we cannot say whether it is differentiable or not. And certain functions, you know the concepts, like sine function is differentiable everywhere. A modulus function is differentiable except in that particular x value when you equate whatever is inside the modulus to 0. Now let us check. Here sin x is there. Now sin x is differentiable everywhere. So no problem. Let us come to this part, that is mod 2x minus 1. Equate what is inside to 0. You will get x is equal to half. So this function is not differentiable at x is equal to half. Otherwise it will be differentiable. Then the product when you consider, that will be differentiable in all the points except x is equal to half. So the option B, which is or minus half, that is your correct answer. You have to check both. This is differentiable everywhere. This mod function is differentiable at all points except x is equal to half. So the answer is or minus half. Is it okay? Seventh sum, f of x is equal to mod sin x. 4 options are f is everywhere differentiable. B, f is everywhere continuous but not differentiable at x is equal to n pi, n belongs to z. C, f is everywhere continuous but not differentiable at x is equal to 2n plus 1 pi by 2, n belongs to z. D, none of these. Now, first let us see. You know, sin x is continuous everywhere, right? And mod function is differentiable at points other than, we have to equate whatever is within the modulus to 0. At that point, it will not be differentiable. Mod function is everywhere continuous. Don't get confused. Mod function is everywhere continuous. But mod function is differentiable only at the points other than, when you equate the mod function to 0, at those points, it will not be differentiable. So here, when you come to this, within mod, what do you have? You have sin x. Equate sin x is equal to 0. You already know sin 0, sin pi, sin 2 pi, etc. So generalization is n pi. So when x is equal to n pi, your sin x will become 0. So it will not be differentiable at x is equal to n pi. So now you check the option B. F is everywhere continuous. That is correct. Okay. But not a differentiable at x is equal to n pi and n belongs to z, because within mod you have sin x. Supposing you have within mod cos x, at that time it will be everywhere continuous but not differentiable at x is equal to 2n plus 1 into pi by 2, n belongs to z. So you should clearly know all the concepts of continuity and differentiability. Then you will be able to tackle the MCQs. So hope you have understood the 7 sums I taught you today. Let us see in the next video few more MCQs. Okay, thanks for watching the video. You have subscribed to the channel if you have not done already. Then you will get notifications of further videos. Thank you.